In this video, we're going to learn how to use Pythagoras' theorem to calculate the distance between 2 points. So example 1. Plot the coordinates 1, 3 and 6, 9. And then in part B, using Pythagoras' theorem, calculate the distance between these 2 points. So we'll firstly look at part A. So plotting these given coordinates. So for that we're going to need a Cartesian grid. And here's the point 1, 3, and here's the point 6, 9. So I've done part A, so moving on to part B, I need to calculate the distance between the 2 points. Now I can show that distance by joining the 2 points using a straight line. And you can see, folks, that we don't have full boxes here or anything. It's not easily measured in terms of the grid. So we need another method in order to do that. Now I suppose the hint is in the question because it's told me to use Pythagoras' theorem. So somehow I need to create a triangle from this. And if I make this if it's a right angle triangle because it's Pythagoras' theorem, if I make this line that I've drawn the hypotenuse, I would then have the two shorter sides being here. So I have my right angle triangle, but I don't really have any lengths yet. So if we look along this horizontal line here, now that's parallel to the x-axis, and on that horizontal line I've got 1, 2, 3, 4, 5 units. So we can see that just by counting. Actually, if I look at my x coordinates in the question, and I've highlighted them red here, the difference between 1 and 6 is 5. So that's where we're getting that 5 from as well. If we look at our y coordinates here as well, we look at the vertical line, that's going from 3 on the y-axis up to 9, which is a difference of 6. And again, we can count that using the boxes, and that gets us our 6 as well. So we've got our triangle now, and because it's right angled, we know we can use Pythagoras' theorem. So we know that the hypotenuse squared is equal to the sum of the squares of the other two sides in the triangle. So we can see that our hypotenuse across from the right angle, that's the longest side, is actually the distance that we need to find. So using our formula, we can have the hypotenuse squared being equal to 5 squared plus 6 squared. Calculating the right hand side gives us 61. We need h on its own, and currently it's been squared, so we need to do the inverse of squaring something, which is square rooting it, and we need to square root both sides here to keep the equation balanced. And that means h is equal to 7.81. Now, we don't know if we're working in millimetres, centimetres, metres, inches, whatever it is just now, so we just write units. And I've rounded the answer to 2 decimal places, so we need to state that. So just now would be a good time to pause the video and copy this one down into your notes jotter. Now, let's look at a second example. Very similar, but this time you'll notice that one of the coordinates involves negatives. So we have to plot the coordinates -1, -4 and 4, 3. And then we have to use Pythagoras' theorem, like before, to calculate the distance between these 2 points. So we need our Cartesian grid again, and here's the point -1, -4, and the point 4, 3. So for part B, using Pythagoras' theorem, calculate the distance between these 2 points. So we know from before that the distance can be represented by a line joining these 2 points. We know that we can create a right angle triangle using these points and the existing line. So the other two sides might look something like this. And we can then see that our horizontal line here has length 5, but we can also see that from our x coordinates, the difference between -1 and 4 is 5. If we look at our vertical line, we've got length 7. But again, if we also look at our y coordinates, we can see we've got 3 and -4, or sorry, -4 and 3, and the difference between those is 7 as well. So we've got a right angle triangle, which allows us to use Pythagoras' theorem. So the hypotenuse squared is equal to the sum of the squares of the other two sides. You can see here that our hypotenuse is what we're trying to find, and that's across from the right angle as shown by the arrow. So that means that h squared is equal to 5 squared plus 7 squared. Calculating the right hand side gives us 74. Square rooting both sides so that we just get h on its own gives us the square root of 74, which is 8.60. As before, we don't know which units we're working in, so we just need to write units, and I've rounded this to 2 decimal places. So that's now the end of this video, but if you pause this before the screen goes blank, and you can copy this one down into your notes jotter as well.